Greetings, everybody! Hey, welcome to our video intro for lab number 9, Parallax and Stellar Properties. Don't bother about what it actually says, even though it says 10, it's actually lab 9. Now, parallax is a geometric technique that's used to give extremely accurate distances to stars. We're going to do a few things associated with that. You're going to be given the parallax shift and the apparent magnitude. I'll show you how that works in 2 seconds. Then you're going to find the absolute magnitude, the luminosity compared to the sun, and then you'll do a couple of other things. First thing you want to do, of course, is read page 142 to 150 to give you some background in how parallax actually works. And you're going to actually, here's the actual data for you down here. This is your field of view. Here are the 2 stars that are actually showing a parallax shift. Remember, what's going on here is the star is actually not moving. It's the Earth that's moving, and that's why the stars appear to shift. The picture on the image on the right was taken January 1, and the image on the left was taken July 1. So this is a 6-month shift. All you have to do is measure this distance right down here between the 2 centers of the 2 stars in centimeters. Write it right there. Incidentally, you're going to be handing in the first 3 pages that have your calculations on them. Then you just take half the shifted distance, and then you're going to follow the instructions here, which are very explicit, to convert that into seconds of arc. And that's important because we can then use that. Let's go on down here and see this. Now you're going to be writing your parallax right here, and then the distance of the star is simply 1 over the parallax. Really nice. And that comes out in parsecs. That's a unit of distance, and a light year equals 3.26 parsecs. So then you can convert it into light years, is what I mean. Okay, so then you're going to be using, she gives us, Gertrude, is the apparent magnitude of that is plus 2.55. And then you're going to be using this little equation right here. You've already this little equation right here. You've already calculated the distance. You've been given the little mv, which is the apparent visual magnitude. We want you to compute the mv. You should show your work right here, and this will give you the absolute magnitude. Now remember, the absolute magnitude is actually can easily be converted into the luminosity, which is what you're going to do over here in this step, using this little equation right here. This is an exponent, by the way, okay? And we'll be able to tell how much brighter the star is from the sun at the end of this step right here. Now, step 5 is, this is the actual classification of the star. It's an A4-5. A4 is the spectral type. That tells you the temperature. 5 is simply telling you it's a main sequence star, which means it burns hydrogen. But here we're more interested in the A4 because you can see between A0 and F0, it goes from 10,000 to 7,500 K. Okay, and so what we're going to have you do is divide up. See this little table right here? Divide up equally between 10,000 and 7,500. You can read about exactly how to do that right here. Write those numbers in here. And the one that you want is A4. That'll actually give you the surface temperature of the star. And you write Gertrude's surface temperature right down here. And then you can easily use this equation. If you have any trouble with it, remember we've got T over T sun to the 4th power times R over R sun squared. That gives us the luminosity over the luminosity of the sun. And if any of you have any trouble with that, this is like stuff we've done in the past. Even in the math review, many decades ago, we did stuff like this. But if you have any trouble with it, you should get a hold of me. Don't just, writhe in pain. And that's pretty much it. The radius of, you're going to be calculating the radius of Gertrude and how much bigger it is the sun. So, if you have any questions, I think that's all I have to say about this. Pretty straightforward Let me know if you have any.